Hello friends, welcome to my channel Physics with Rakshi. In the present video, I will introduce information theory with the introduction of classical information and quantum information. So let's start. In 1990, John Wheeler proposed that information is the basics of physics of our universe. He also came up with the phrase that it from bit. It means that whatever is present in our universe, whether it is particle, fields, space-time, gets its function, meaning and existence by asking binary like questions, that is yes, no, high, low or 0, 1. In short, all things or objects in our universe are information centric in origin. By getting knowledge of this binary system or information, you will have knowledge of complete universe according to modern information theory. In the present video, we will define information in terms of entropy, and by the end of video you will get that there is a deep relationship between information and entropy. There is also deep relationship between information and time also. I will explain relationship between information and time in my next videos. So, in classical information theory, basic unit of information is bits, while in quantum information theory, basic units of information is qubits. What happens in quantum information theory? It is difficult to measure quantum state in terms of quantum information. That's why non-commutative observables cannot be evaluated in terms of uncertainty principle because of uncertainty. That's why eigenstates in basis is not matched. Therefore, it is advisable to make easier quantum information theory in terms of definition of entropy. So initially we will study various definition of entropy. Thereafter, using entropy, we will define information and quantum information in terms of von Neumann entropy. So here I have given that equation of thermodynamic entropy, that is minus k beta summation j pj ln pj, where pj is probability of happening and pj is defined in terms of omega, that is number of microstate corresponding to given macrostate, that is pj is equal to 1 over omega. So if we consider mathematical entity omega, we will have equation of Boltzmann entropy, that is A is equal to k beta ln omega. So this is the equation of entropy. Thereafter, various physicists like Hartley, Shannon and other scientists proposed modern information theory in terms of binaries. Also, they gave definition of information in terms of binary. Suppose we will have a state in terms of binary in messages, that is 10101. Here, since number is binary and we will have 5 number, here capital U is equal to 2 and capital N is equal to 5. So this state or information increases with the number of equiprobable messages, that is U raised to N. And using this equation, one can define equation of entropy, that is I is equal to capital N into f of U is equal to G into G of U raised to N. Here f of U is equal to C into ln U, where C is any positive constant. By generalizing the equation of information, we will have this equation, that is I is equal to minus C summation j is equal to 1 to U into Pj ln Pj, where Pj is probability of happening. Physical significance of this equation is this equation gives entropy in terms of information, which is missed information or incomplete information, because in nature no system has zero entropy. That is why we cannot have complete information of any system. So this equation defines entropy as missed information or incomplete information. Thereafter, von Neumann came up with the idea of density matrix to define entropy for quantum information. Density matrix is used to define statistical ensemble of quantum states. It also used to define pure and mixed quantum states. So density matrix rho is equal to summation j pj ket vector psi into Bray vector psi. So here one should note that if we will have probability 1 or unity, we will have complete knowledge of given quantum system, which is impossible. Or in other words, pure state of quantum system have zero entropy, which is also impossible. That is why in nature we will have quantum system having mixed states. So using the definition of density matrix, we will have equation of von Neumann entropy, using which one can define quantum information. That is S equal to minus stress rho ln rho is equal to minus summation j rho j ln rho j. So this is the equation of von Neumann entropy, which is the basic equation using which one can expand quantum information theory. So in the present video we have seen why information theory is important in physics. We have seen phrase given by John Wheeler, that is it from bit. We have also seen that basic unit of classical information is bit, basic unit of quantum information is qubits. We have seen various definition of entropy. Thereafter we have seen definition of information, and at last we have seen definition of von Neumann entropy in terms of density matrix. Quantum information theory is the basis of quantum computation, quantum entanglement and quantum teleportation, and all knows that at present in current frontier, quantum computing and quantum technology is emerging day by day. That is why concept of quantum information is very, very important. Thanks for listening and watching. If you like my videos, please share and subscribe my channel. If you have any question regarding quantum information theory, you can ask in the comment section. Thank you very much.